Thank you, Camilla, for the introduction. So I'm very excited to be here. It's my first talk ever at Nodes and hopefully not my last one. I'll be talking about GitHub Actions, and I will show you how you can use GitHub Actions to build, test, and deploy every single change of your Neo4j custom code. Before we start, just a few words about me. My name is Chris Cook, and I'm from Germany, even though my last name doesn't really sound German. I recently got married and thought this new name sounds a lot cooler than my previous name. I started doing software development when I was 14 years old, back when we were just using PHP and MySQL for websites. And on the job site, I worked for a big German company for more than 10 years as a software engineer, doing mostly SAP enterprise development. Over the last few years, I co-founded a young software startup with two friends, and we are in the midst of developing a graph-powered data collaboration platform. Go check that out if it sounds interesting to you. We are currently looking for beta testers. And you can, of course, find me on GitHub, LinkedIn, or you can check out my blog at DevTO, where I post all my technical stuff. Okay. Now let's see what we got here. First of all, this presentation is a bit interactive as I will switch between my browser and Visual Studio Code and Neo4j Desktop. So if I'm going too fast, you can find this presentation here on that link, and you can just follow in your own pace. We will start with a short overview of what we mean with custom code. Specifically, we will be looking at user-defined procedures and functions. Then we will go through the steps to build, test, and deploy our own user-defined function. You will see that it takes quite some time to deploy it. So that's the reason we'll be looking at GitHub Actions to see how we can automate this process. And at the end, I will show you such a workflow that I've set up for this presentation. And yeah, give a demonstration of that. Hopefully everything's working fine. So let's start with the first slide. Neo4j can be extended with custom code that you can call directly from your Cypher statements. There are multiple ways you can write custom code, but we will be looking at user-defined procedures and functions. User-defined procedures is a way to call your code from your Cypher statements. They can return multiple values, and they allow update operations, so you could create nodes and relationships, update them or delete them during the execution. Those procedures must be called with the call keyword. You've probably used them already. I have an example here of the epoch.load.json procedure that fetches the given JSON URL and returns it as a stream of values. Epoch is a good example of a collection of user-defined procedures and functions, and I guess most of you are familiar with those. User-defined functions are lightweight procedures in a sense, because they can only return a single value and only allow read operations. You can call them without any keyword, but only as part of other Cypher statements. So you can't call them standalone like you can with procedures. The second code example shows epoch.date.parse function, which converts the given date string here in a numerical unit. In that case, it's seconds, and that will give us the Unix timestamp for today's date in UTC. There are lots of built-in function and procedures, and also your installed user-defined procedures and functions, and you can list them all by running show procedures or show functions in your Neo4j desktop browser. Okay, so that was just a bit theory. Now we will take a look how we can build our own user-defined function. I created this slide here, but I think it just makes more sense if we look directly at the code. So I'm going to switch to VS Code directly. I hope you can see my screen. This example is copied from the official Neo4j template on GitHub. I've linked to it here and in my presentation. We have a Java class here that has one method, the join function. That is our user-defined function. It has certain attributes, for example, description and 2 arguments. And what this function will do later is it receives one or more strings as a list, and it joins them or concatenates them, the strings, with a separator that we provide as the second argument. Then, of course, we always should be testing our code. So that's the reason we create a test class, join.test. This code is also copied from the official template. We have some setup code here, and specifically during the before all step, we are going to start an embedded Neo4j server that just runs during the test run, and that loads our user-defined function. And then we can access it during our test. The test method here connects to the embedded server and then just submits a Cypher query. In that case, we are just calling our user-defined function with some arguments, and we are reading the result. And then, as we already do with testing, we check if the received result is or matches the result we expected to receive. Okay, then what comes next is we have to compile and package this code. We are going to do that with the Maven package command. What this command does is it first compiles our code from Java into the bytecode, and then runs the tests that we defined here. And during the test run, I can show you what we get out of it. It's, if you look at the left here, the target folder, there's an example file example and then version number. That's the Java archive, and that is the file that we compile to and that we will later use to deploy to the server. It exists because I pre-compile it, because as you can see, it takes a few seconds to do it. The test runs completely. It's done. You can see it here. So no errors in test, and we get a fresh file here. And we will use that file in a few seconds. Let me quickly switch back to the browser. I'm going to skip the test step, as I've shown you this also in VS Code. We have to get that Java archive file, and it's also called the plugin. We have to get it somehow to our Neo4j server, to the remote server. And I've described it step by step here on the left. And you can find the same steps, the commands for the command line on the right side. So first of all, we have to upload the file to the remote server running Neo4j. That depends what kind of server you are using. And then we have to log into that server, for example, via SSH. On the server, we have to execute a few commands. We have to move the Java archive file to the plugins folder, which is usually located at this directory if you didn't change the config. We have to change the owner and group of the Java archive to Neo4j. That's strictly speaking not required. I didn't find it in the docs, but it did solve a few access denied issues I had in the past, so it doesn't do any harm. We have to make the file executable, and then it's an important step, and we only have to do it once. We have to add the plugin, the Java archive, to the Neo4j config. Neo4j follows a whitelisting concept when dealing with custom code, and it only loads code that we added to the config. So have to do it once, and I link to the official docs here. Last step is we have to restart the Neo4j service on the server, because then on the next start, Neo4j will pick up the user-defined function. Okay, now I will quickly switch over to Neo4j desktop. I've done those steps in advance because it takes some time to execute them, and I didn't want to do something wrong, so I've already done it before. First step, to verify if it was deployed correctly, we can just call show functions. And as I said, it gives you all installed functions, a lot of built-in functions that you probably use all the time. And I will scroll down to 300. So give me one moment. And one more, and it's here. Example.join, that's our function, and that's the description that we have implemented in the Java class. And the second step is you can just call the function and see if it works. So we're going to invoke it, return example or join. With a list argument, our strings that we'd like to join can also add more, and a separator argument afterwards, and then just execute it, and it gives us hello nodes as a string. Perfect. Let me quickly switch back to presentation. So now imagine you're doing a change to your code, and you have to repeat all those steps all the time. So compile it and test it. Of course, you have to do it anyway, but you have to deploy it manually all the time. So that takes quite some time. That's the reason we are looking at GitHub Actions and how to see if we can automate this process. First of all, what is GitHub Actions? GitHub Actions is a continuous integration platform that's directly integrated into GitHub. And it allows you to set up a certain pipeline that you can use to build, test, and deploy your code. It's integrated in your pull request. It's integrated in a lot of other things, so it's quite easy to set up a workflow or a pipeline. I've created this diagram and wrote a lot of words here, but I think it's just way better to see how it looks like directly in VS Code, how such a workflow could look like, because GitHub made it quite easy to implement it and understand it, so it just makes more sense to talk about it directly. Here in the folders, we have a special folder called .github. It's a folder for all GitHub related stuff, and there's a subfolder workflows. And here lives our workflow, and we can also have multiple workflows, so you can have multiple files. Each file is a workflow. As you can see, it has a certain name that doesn't really matter, and it has a file format YAML in that case. And let me quickly collapse that before we get started. What is it? That's all we got. That's our workflow. It's a template describing an automated process in YAML format. And this workflow can be started manually, so we can start it on the GitHub UI. It can run on a certain schedule. For example, it can run every night, or important for us, it can run by repository events. So what are repository events? All the activities that happen in your repository are events that can trigger workflows. For example, pull requests being submitted, issues being opened, comments being added, and of course, every Git commit and push is also an event. You define those events or those triggers with the on keyword here, and then you say on push. So that's it. That defines that every single push that we do to our repository ends up starting the workflow. We can add a filter here to branches, which says only the main branch should, to get it here, only the main branch should trigger that workflow. There are other options like pull request and issue comment that could also trigger the workflow. A workflow consists of one or more jobs, and those jobs run in parallel by default. That's the first thing that should be noted. So when you define multiple jobs, they all run at the same time when the workflow started. But of course, it makes sense to have a certain order. For example, you only want to do deployments when your build and test has succeeded. So you can create dependencies between those jobs. So we will open the deploy job because that's a job that runs when we only when the build job has succeeded. So we open that and we can see there's a keyword needs. So needs defines a dependency that says, okay, only execute this job when the previous job build has succeeded. So that's the first thing. Then those jobs here build and let me collapse that for a second. Build and deploy, they run on a certain system, which is called a runner. Runner is just a virtual machine that runs a certain operating system. In that case, we have Linux or Ubuntu, but we can also use Mac OS or Windows. Or you can even host your own runner with a different operating system or flavor. Those runners, they only exist during the lifetime of the job. So they are created for that specific job and they're destroyed afterwards. During the execution of the job, there are multiple steps that are executed in order. So they're not parallel, they are executed as they are defined. What you can do as steps of a job is basically you can do anything that the operating system allows you. A step can be a simple shell command. It can be a more complicated shell script with multiple commands, conditions, loops, and so on. Or it can be a so-called GitHub action. What is a GitHub action? That's what we are concerned here with. A GitHub action is a custom reusable unit of code that we can create on our own, and we can create it and save it in the .github folder here. Or we can install it from the GitHub marketplace, because lots of other people have created GitHub actions, and we can just search for them and install them and use them. So it's like an app store for those actions. A GitHub action is also just simply a shell script. It can be JavaScript code, or it could even be a Docker container. The job, as I said, lives and runs on a certain operating system, on a runner, and that only lives as long as the job is being executed. So it also only has a certain amount of software installed. So if we need specific software, for example, we need the Java development kit in a specific version for our code to compile and package. So we have to install it. So I will just open that up. Setup JDK is simply an action that we can install from the marketplaces, and we give it 2 arguments. We say, okay, we would like that specific version, 11, and we use Maven as project. And then it sets it up during the job execution, and we don't have to worry about installing anything. Another step is, as I've shown you before, we are building and testing with Maven. So that's simply a command that we run on the shell. Just Maven clean package, as I've used before. Then there's one more thing I'd like to mention is caching, because that job only lives for a certain amount. We have to share the Java archive that we created with the following deploy jobs. So what are we going to do? We have to cache it somehow. That's what this action does. It uploads the resulting file, and we can then use it in the next step, in the next job here to restore it back from the cache. So that's the way how we can reuse artifacts between jobs, or even reuse them between different workflows. Okay. Let me quickly switch back to the presentation here. As I said, you can explore the presentation on your own, and I've added some words. I just thought it's so easy. Just let's talk about code directly. I've also created a second slide here that shows you that whole workflow again. And as I said, it's just a visualization of the code we were talking about. And let's do a real world example. Switching to my next slide, demo. What we're going to do now is we are going to do a small change in our code. Then we're going to commit and push it to GitHub. And then we see how build, test, and deploy runs automatically by our workflow. And then how we can use it directly afterwards in Neo4j desktop. So I will quickly switch to Visual Studio Code again and close that for a second and open first our class here. I'm going to implement a small change. I will call collections.reverse. And what it does is we get that argument, the strings here, as a list, and we just change the order. So it's just different order than before. Then, of course, we also have to test our change. So we have to go to the test class and test. And it's now a different order. So we're going to comment that out. And it's now, as I said, we reverse it. So it's node, comma, hello, that we expected. If I would not change it, the test case would fail on GitHub. I can show you that in a second. We're going to change it. And We're going to be lazy. We don't test it locally. We're just going to push it directly to GitHub. So I give it some comment and then comment and push it to GitHub. And now we will be switching to the browser. And I have a second tab here with the repository. I've set it up for this presentation so you can explore it later. GitHub has a tab here, Actions. And when you click on that, you will see our comment that I just pushed up. It's just running the workflow. And I've done some comments before, so you can see all the execution from previous runs. You can see on which branch they're running and which commit triggered that execution and by which user and so on. They're going to check that particular execution. So as I said, first the build job runs, and then we have the dependency here that calls the deploy job. So build has succeeded, and we can take a look at the job execution log. And it's, as I said, the same as the YAML file that I showed you. We have the steps, check out repository, set up JDK, build and test with Maven, which is exactly the same output that we got locally. So you can collapse it again, and we cache that artifact. That's it. As you can see, it's pretty fast, so you don't have to worry about you have to install the JDK and all that stuff. It's not like you're installing something on your Windows laptop. It's these are actions created by GitHub, and they run pretty fast, so don't have to worry about it. As you can see here, and also if I head back to the overview, here, you can see, okay, build and deploy was successful. So let me switch to Neo4j Desktop. I'm going to call the same. We are going to call our user-defined function again. I have the previous output here, and I'm just going to call it. And you can see, note that it was this before and it's now this. I mean, it's pretty basic, but it's just, it took us literally, when I switched back, to 1.5 minutes to build, test, and deploy the change on GitHub without any manual process except implementing that. So that's quite cool. Of course, that's pretty low stuff, because you wouldn't usually just push any changes you make to your code to GitHub and then deploy it to your server directly. But it just should give you a feeling of what is possible with GitHub Actions. And there are certain other things that you can do. You can implement reviews so that people have to approve before the job runs. So you can say, okay, 5 people have to approve this commit or this pull request before we deploy to production. And you can do lots of other cool stuff. So I encourage you to explore that, and I hope you enjoyed that. And yeah, that's it from my side. I have this repository here, and you can explore it yourself. I've linked to lots of stuff. I've linked to my presentation. And yeah, if you want to find out more, then go to the FTO, check out my blog. I've blogged about GitHub Actions, also how you can use it to start workflows when someone makes a comment on your pull request, and other cool stuff that's possible with GitHub Actions. Okay, I hope you enjoyed that, and see you soon.